Okay, questions 16 through 23 are all solving problems that involve either exponents or logs. Notice that some are no calculator problems and some are calculator problems. The answers can be exact or correct to 3 decimal places. Obviously, on the no calculator problems, you're not going to go correct to 3 decimal places. You'll do an exact answer. So as we look at number 16 here, we need to get e to its power all by itself. So we're going to add our 7 to both sides, and we have 3 times e to the 2x equaling 57. Again, we need that e by itself. 3 is attached to that e by multiplication, so we're going to divide by 3. And we have e to the 2x power equaling 19. To solve this, we need to use an inverse operation, and the inverse of e is ln, so we take the natural log of both sides. And we end up with 2x equaling the natural log of 19. Divide by 2. It wanted a no calculator answer, so we're going to leave it like that. X equals ln of 19 divided by 2. Next one, this is an exponential form, and there's nothing else I can do to simplify. And my basic rule of thumb here is when you're in exponential form and you can do no more, make it a log. So this log base is going to be 2.8 of 345 equaling x. I don't know if your teacher showed you, but it was, remember we did drop and crisscross, and that was the Roman numeral 9. It's another way of remembering that. And then again, the newest calculators can put that in directly like that, and the slightly not newer ones are going to put this in using the change of base formula, log of 345 divided by log of 2.8. That's the exact answer, or this is the exact answer. Both of them are. But when you stick that into the calculator, log of 345 divided by log of 2.8, x is equal to 5.675. Again, remember to round correctly to the 3rd decimal place. 18. Okay, so there's a whole lot I need to do before I make this log form. I'm going to subtract first, so subtract our 20. Wow, what's happening here? We have 5 times 2 to the 3x minus 1 power equaling 500. I'm going to get rid of the 5 first because we need that base and the exponent by itself. And we have 2 to the 3x minus 1 power equaling 100. Now, I can't make 100 into 2 to any power, so to make the same base and exponent, so you can set the exponents equal to each other. So the only other option is to make this log. So log base 2 of 100 equaling 3x minus 1. Again, drop and crisscross. So this is log of 100 divided by log of 2, if you're doing in the calculator, equaling 3x minus 1. And then you're going to add your 1 and divide by 3. So again, what I'm doing here is log of 100 divided by log of 2. I get that answer. I add the 1 and then divide by 3. But if you're showing an exact answer, the whole thing divided by 3. This is the exact answer. If you're putting that into the calculator, that answer for 18 is x equals 2.548, which I expect most of you will put for an answer, as opposed to leaving the exact on a problem like this, where you have access to a calculator. All right, here we have ln. There's nothing I can simplify on it. And again, once I'm stuck in ln or log form, you make it an exponent. This base is e. It's not showing up. So this is e to the power of 2 equaling x plus 4. So if we're solving again for x, move your 4 over by subtraction. Whoops, that looks weird. I'm going to just rewrite that. E to the 2nd power minus 4 equals x. That is the exact answer for 19. In your calculator, second ln is e to the power of 2 minus 4 is going to give you x equals 3.389. Number 20. Again, there's nothing I can do to simplify here. You're not allowed to add your 1 because it's caught in parentheses here. So all I can do is make this an exponent. 7 to the 2nd power equals 3x minus 1. Drop and crisscross, same thing, Roman numeral 9. This is 49 equaling 3x minus 1. Add your 1 to both sides. If you want the exact answer, it's going to be 50 equaling 3x. So 50 over 3 equaling x is the exact answer if rounded to 3 decimal places. 16.667 equals x. 21. This is the reason we learned our rules for condensing and expanding. So this is expanded form. So condensed form, there's a plus in between. So this is going to be log base 5 of x times x minus 4. That's condensed form, equaling 1. There's nothing else we know how to do here, so we're going to make it an exponent. Again, if you're stuck in log form, make it an exponent. 5 to the first power equals x times x minus 4. Go ahead and distribute here. And 5 equals x squared minus 4x. It's a quadratic, so you have to solve that. Get the 5 over to the other side, and you have x squared minus 4x minus 5. So x and x, the factors of negative 5 that add up to positive 4 are negative 5 and positive 1. So we have two potential answers here, x equals 5 and negative 1. This x here is not allowed to be negative. So therefore, this is an extraneous solution. And the only solution is x equals 5. Because again, you can't have log base 5, like for example, of negative 1. Because 5 to what power equals negative 1? There is nothing. If you had 5 to like any negative exponent, it would give you a fraction, not a negative number. 22, condensing again, log base 2. And then this becomes division because it's subtraction of x plus 5 over x minus 1. And then this is equal to log base 2 of 2 to the second power. And 2 to the second power is 4. Since we have log base 2 on both sides, essentially you end up dropping those, or you can do 2 to the power of log base 2 of 4 equals x plus 5 over x minus 1, which is essentially the same as taking x plus 5 over x minus 1 and set it equal to 4, because 2 to the log base 2 of 4 is just 4. Cross multiply and solve. We have to get rid of this x minus 1. So we have x plus 5 equaling 4, x minus 4. Get the x's over to one side and the numbers to the other. And I get x equaling I apologize, 3x equals 9. I knew something was wrong here. And divide by 3. X is equal to 3. And again, just double check to make sure you're not going to give yourself problems over here. This is going to be 8 over 2, which is a positive number, so we're good. Last one in this section is number 23, excuse me. When you see these problems with two terms, one constant and one a log that's not, move that log to the other side. Absolute easiest way of doing this problem. So now what you have is a problem that says 2 is equal to log of 20 plus log of x. You know how to do this because this is expanded form, you want a condensed form. So this is log of 20 times x. Now, what is the base of that log that's not showing up? It's a 10. There's nothing else we can do here except for make it an exponent. 10 to the second power equals 20x. So 100 is going to be equal to 20x. Solve, and we're going to get x equaling 5. And again, log 5 is fine. That answer looks great, and that is the solution.